So guys, let's get this formula sheet out of the way, and then we can just open up whatever you want to talk about. Examples you want to do, practice test stuff. I've got a little copy out of the book of something in case we don't have enough questions coming at me. I go a little insane when that happens, so I can pass it out, let you guys work on that. All right. So obviously we can have stuff like the formula. If you want to put it down, you can put the formula for the mean. This might actually just get in your way, because you know how to find the average of something.
Will the formulas be on the test? Or?
We are making a formula sheet that you can bring with you, and you'll turn in when you take the test.
Okay.
So make sure, and do this favor for me now. Formula sheet, you can't, I don't want it ripped. I don't want anything crossed off on it. Do you understand? If it's ripped, what was on the other side? When did you rip it? Yeah. I don't, as we go through the rest of the semester, you can put more and more formulas on this sheet and keep bringing it with you to the test. Do you understand what I'm saying? So don't feel like, oh, I've only got a few formulas, I'm going to rip it because no. Just keep adding to that one sheet. And then it could be your final exam formula sheet that you can bring. Let me see. So we got this guy, and then we have the formula for the variance. Let's see, actually, we'll put the variance formula down here. Remember this guy here? Let's put S. Sorry. Hopefully that looks familiar. And of course, so that's the variance. So for example, you can't put the word variance here. It's a formula sheet, not a word sheet. So what do you have to do to get the standard deviation? Square root it. So you could, if you wanted to, you could put S equals square root. Right? Or don't, because it's really the same thing. I like it, I like it. So any suggestions on other things from chapter 8 that you think we should be able to put down here?
Something about standard deviation?
What about it?
Oh, wait, there's no formula for that, is there? Oh.
Anything else? Yes?
That is for the amount, the difference between the numbers?
No. If I had a list of 28 numbers, what would n be? What's the value of n? 28. And then so 28 minus 1 is what goes in the formula. But what's n? It's the size of your list of data. It's how many, it's the number of data points that you got. That's why we chose the number, the letter n. Math people, sometimes we try to make sense. Letter N makes sense there. So remember, you also have mid-range, but you really should know how to get that. How to get the mid-range. Divided by 2. Average the high and the low. Right? How you get the range? High minus low. How far does it go? Right? Yes?
I had a question about the median. So when your data is like, it's not in order, it's just kind of like high, low, high, low, high, low. When you calculate the mid-range, do you have to should you be putting it in order and then finding the ones in the middle? Like, so if it's
So to find the median, the numbers have to be in order. There's no other. You have to. Otherwise, you could put them in any order. You can make any number you want to become the median. That doesn't seem fair, right? The median house price is $1.
Yeah. Okay.
Wait.
So then you want to rearrange it, put it all in order.
Yes.
And then.
So the median only makes
number,
sense.
Then you can add the 2 in the middle
Cool.
and then divide.
I like it.
Okay.
So the whole process of, if you have 5 numbers, there is a middle number, right? So that would be the median. If you had 4 numbers, there is no middle number, so you have to do what?
Yeah. From high to low, right?
All right, we'll do that in a minute. We'll review that in a minute. Formulas. So then you have all the formulas, the probability formulas from chapter 7, right? So before I left chapter 8, I want to make sure. So chapter 7, you got this kind of stuff. We use this symbol
Bless y'all.
for given, right? Do they? Oh man, I guess not. Yeah, they do. Okay. How do you read this? Does somebody remember how you read that? Yeah, okay. So probably A given B. So given that B happened, what's the probability of A? Given that the person just got off of a motorcycle, what's the probability it's a man? It'll change, right? So this will be, the given thing goes on the bottom, and the and is on the top. By the way, we're all painfully aware of how horribly I write, so I would highly suggest you double check all of these in the book that's written by, typed up by a computer. Because I always hate it when somebody makes a formula sheet and they have something wrong because they misread something I wrote. It's your responsibility. Go make sure that you got the right formula down. But these are the ones you're allowed to have on your sheet. And then this guy. Now, to be honest, most of the probability problems we do don't require the formulas, really. It just count. They give you a table of stuff. You really don't need the formulas at all. You just count what's going on. All right, so any other suggestions for formulas that should be on your formula sheet you should be able to have? Anything I forgot, left out? Okay, so remember, you will lose points if you have more stuff on there than you're allowed. No words. There's already words here. I mean, when don't you use or? Well, probably the one that says or. Right? You can't put little variance there. You can't put stuff there. No words. I like it. Just the formulas. I don't make you memorize the formulas. I make you recognize the formulas. Now, a few more people come. Anybody else need a copy of the practice test? So we got that? Alright. Now it's wide open. Whatever you guys want to talk about, yes.
Section 7.7, question 76.
Which one?
7.7, question 76.
76? Oh, okay. Alright. I should leave these up here for a little while. I love when we start with one of the hardest questions in there. If this is the only problem you had trouble with, then you're fine. I mean, this is critical thinking exercise, which normally translates into bonus situation, right? But 9 cards numbered 1 through 9 are placed into a box, and 2 cards are selected without replacement. So,
Which one is this?
76.1.
thank you.
6.
No,
7.7. Alright, so they put the cards 1 through 9 in a box, and then 2 cards are picked, what's it say? Without replacement. Find the probability that both numbers selected are odd, given that their sum is even. I like it. So can somebody when I say the word sample space, what does that mean? You guys know what it means? Sample space. All the possible things that could happen. So what could I get? What's the lowest kind of numbered cars? What could I get first? I could get the number 1. Could I get the number 1 again? No. So I get the number 1 followed by 2, 3, 4, 5, 6, 7, 8, 9, right? And then I can get the number 2 followed by 1, 3. So just not going to include 2, 2, right? Why won't I include 2, 2? Because I'm doing it without replacement. I can't get 2 and then 2 again. How we doing? If I do, that's a very strange ability to have. I can make another 2 appear. Oh, that's useful. All right, is everybody with me on this? What could you cut out? What could possibly happen? You can put the number 1, throw it away, feed it to your little brother. Then you can get the number 2. Or you get the number 1 and the number 3 and so forth. And the same thing with the 2s, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8, 2, 9, and so forth. So it's just all going to be missing. The 3 3s is going to be missing. 4 4 is going to be missing. I like it. Okay, so you need to come up with a way. Yes, sir?
I'm just wondering, is the line between the A and B right there, is it a parenthesis or is it divided?
This here?
Yes.
What does that line mean? Given. Given. I like it. So let's do this way instead. Instead of writing every single one, what do I know must have happened? What am I told in this problem is definitely true? In this problem, what do I know is true? I'm trying to find the probability that both cards are odd. What am I told is true? What am I told is true? Anybody have their book? Yes, given that their sum is even. So I know their sum is even. So instead of writing all of these, which sums of these? The 1, 3 is even, right? So 1, 3, 1, 5, 1, 7, 1, 9. So you're going to have a much smaller list now because I can just focus on those. Why can I only focus on those? Because I know they freaking happened. One of these things happened. Their sum is even. So I'm not going to write 1, 2. It didn't happen. What could have happened with the 2s? 2,
4.
2, 4, good, because 2, 1 couldn't have happened.
Wait, what's going on?
So many things. You need to be with me. So what do I know in this problem? Given that their sum is even. So could a 1, 2 be a part of this?
No.
Because the sum is odd. All right. 1, 3 could. 1, 4 no. 1, 5 could. 1, 6 no. 1, 7 could. So forth. 2, 1 is odd. 2, 2 can't happen anyway because I can't pick 2 twice. 2, 3 is odd. So 2, 4 is the first 2 guy that can happen. 4 little 2s. 2, 4, 2, 6, 2, 8. Now keep going. And the beautiful thing is, once you write all these possibilities down, what about for 3? It would be 3, 1. 3, 3 can't happen.
3, 5.
3, 5, 3, 7, 3, 9. You guys understand what's happening?
Yeah.
I'm just writing all of them ones that would have a sum that was even. Why can I only focus on those? Because I know that one of those happened. It told me that their sum was even. So one way to do this problem is to write the whole sample space out. And then the question is, what's the probability that both numbers are odd? Well, so far, I got 1, 2, 3, 4, 5, 6, 7, 8. But hopefully you start to see a pattern that might be true here. What about for the 4s? What would it look like for the 4s? 4, 2,
4, 6.
4, 6,
4, 8.
4, 8. 4, 4 can't happen, right? 5s. 5, 1. 5, 3.
5, 7.
5, 7.
5, 9.
How many odds does it seem like there's always going to be?
4.
If the first number's odd, there's going to be 4. If the first number's even, there's going to be 3. That pattern does continue. So there's a quicker way to do this problem. And again, my God, people, did you hear what I said first? This is a really crazy question to start with because it is almost a bonus question. It's in the critical thinking part. So that means if you did everything else beautiful except for this problem, you're exactly where you want to be. But this is how you would do it. Now, I could already see, I'm not going to count any of the even ones ever because the question is, was probably they're both odd. And they have to both be odd to add to be an even number. I don't know if you guys see what I'm saying. There's a lot of ways to truncate all this work. I'm not going to write more. That's enough shit. So for the 1s, 3s, 5s, 7s, and 9s, for the list to have those first, there's going to be 4 each. 1, 2, 3, 4, 5. So there's 20 like this. 20 total combinations. What about for the even numbers? 2, 4, 6, 8. There's going to be 3 each. 1, 2, 3, 4. So there's 12. That's how many even first numbers are going to be. Where are all my ones they're both odd? Well, all of these. Every single one of these. So it'll be 20 out of... How many total do I have? 32. So it'll be 20 out of 32. And again, if you didn't quite get that, I almost don't care because it's a bonus question. Right? It's a little beyond what you have to be able to do. But you can notice a lot of... you can just write the whole damn thing out. I don't care. You can do it that way, beautiful. But there's no need to. You can start to realize, oh, there's repeats. There's symmetry to this. There's a pattern to this. All right, so let's take it down a notch. Any non-last problem questions? Yes?
Sorry. 7, 1. We can do either 15 or 24.
Let's do 15. Because again, 24, if you're only having trouble with that one, you're fine. Has everybody got the formula sheet here? Everybody understand that you're required to bring this formula sheet with you? If you do not have it, you're going to have a bad time. Or you might remember this, you never know. All right, so 15, this is section 7.1. It says you're taking a multiple choice test that has 5 questions. There's 5 questions. Each has 3 choices. Like A, B, C, right? Blah, blah, blah. If you select one of these 3 choices for each question, leave nothing blank. In how many ways can you answer the questions? I like it.
What confused me at first was I thought it'd be like, oh, so I just multiplied 5, 3, 1, but when I took my answer in the book, it made no sense.
Of course it didn't. I don't have 3 questions I'm answering. How many choices do I have to make? How many choices do I have to make?
3?
No, that's how many options I have to choose from. How many times must I make a choice? How many questions are there? 5. So don't you have to make a choice for each question? So how many choices do I have for the first question, the second question, the third question, fourth question, fifth question?
Oh, so there's 3 times 3 times 3 times
3 to the 5th power, yeah. So every time you must make a choice, that's going to be a number of how many options you have for the choice times the next one times the next one. So real quick, if I just focus on 2 of these. So like A, B, C for the first problem, and the second problem is A, B, C. So let's try to write this out, because this would be way too much for this, but now watch. So what could I choose? I could choose both A's, right? I could fill in both A's. I could fill the whole damn thing in A if I want to. But for the first 2, I could get A, or A, B, or A, C. So for the A, I've got 3 second choices to make. What if I choose B first? Then I can choose B, A, B, 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 C, right? What if I choose C first? C, A, C, B, C, C. So how many total choices are there for the first 2 questions?
9.
Count them, yes, 9. Good. This is just counting. This is not real math. This is just count. I wrote all the possibilities. Is that cool? This is all the choices you have for the first 2 questions. I wrote them all down because it was quick. If I want to write it for the whole test, holy shit, this is going to be a long. In fact, it's going to be this long, whatever that number is. But I just did the first 2 questions, so how long should that list be? 9. It's freaking 9. Because for each one of these I choose, I have 3 options for the second one. And how many options do I have for the first one? 3. So 3 times 3. It's the definition of multiplication. That's why the fundamental counting principle makes complete sense. But you noticed the one little thing to be careful about is how many true choices do you have to make? You put that many blanks down. And then how many options do I have for each choice? That's what you fill into the blanks. So it's like that license plate problem on the practice test. Yes?
Either 39 or 41 on 7.7.
7, 7?
7.7. Either one works.
39 or... Oh, I see. All right.
Specifically, how do you get half of the total once
Half the total. Let me see. A political discussion group consisting of 5 Democrats, 6 Republicans, and 4 independents. 2 group members are randomly selected in succession to attend a political convention. Find the probability of selecting blah blah blah. Okay, I like it. So again, this is section 7.7. This is what they talk about and conditional probabilities, right? So this says now obviously, am I going to pick the same person twice? No, I need 2 people. So is this with replacement or without replacement? Am I picking one and then putting them back in? No, I'm picking one and saying stand here. Let me pick somebody else. Is that cool?
Yeah.
So that means that things are going to change through the problem because I'm going to have fewer people. I'm going to take one away, so there's going to be fewer people. So the probabilities are going to change. I've got 2 people I got to choose. So so for this problem, let's say number 39. It says an independent and then a Republican. Cool. So what's the probability that the first one is an independent?
4 out of 15.
Yeah, 4 out of 15. So I pick that person and I put them there, that independent person. What's probably the next person is a Republican? 6 out of
14.
14. Because now there's one less person and I just pick somebody. Do you see that? If I had done it with replacement, then it would have still been 6 out of 15 here because I would have put that first person back in.
I did that, but when you add it up, I'm not going to do it now.
So multiply, right?
But not, I did exactly what you did, but when you look in the back to verify it, it doesn't matter.
Well, let's see here. We get 2 7ths and you get 2 5ths, right?
Yeah.
So then you get 4 35ths. Yeah, there you go. What happened?
I didn't reduce it down.
Oh, yeah. So if you just get 24 over whatever,
Yeah.
you got to reduce it, yeah.
Yeah.
I reduce first when the numbers are small. Don't reduce after when the numbers are big. That's crazy. I like it. Cool. And thank God you got a teacher that grades more on concept. So if you don't reduce it at the end, it probably won't take any points off. It really doesn't bother me then. What really matters is you understand how to set it up. Yeah. All right. Yeah.
Practice test. Question 1 for C.
Did you have a question on this here or different? Okay. 1C.
Yeah.
Oh, it depends on you doing 1B correctly first, right? So let's do it. Let's hold off on that because I think I might do some of that together with you guys. So we'll look at number 1.
7.4, number 63.
So let's see, a person who moved within the same state, and let's see what it says. Oh, this they give you in the millions, but that part doesn't really matter because when you divide, the millions cancel anyway. All right. So let me see. So very quickly, let's see. Owner, renter. Same state, different state, different country, different planet. No, all right. Different country, we'll stop there. So they give you this stuff. This is decimals because it's in the millions. You know I love this kind of problem, so you know I'm going to give you a problem with a table, right? And the very first thing you do to answer any questions I ask you is to do what here?
I don't know.
Add them up, so you see all the totals, because all the probabilities will depend on those totals, right? It's going to be what's on the bottom. So here I get...
This is 66.
63.
Okay.
Section 7.4. So it's this problem here, right? Yeah, okay. So when you add these up, you get 30.4, 7.3, 1.3. And you add these up, you get 14.8, right? 24.2, I think. And let's see if we get the same thing. So I get 37.7, looks like 39, and then here I get 39, thank God. All right. It's a nice check. It's got to add the same thing here as there. You better have the same amount of people, either way you look at it. This one person is kind of like phasing in and out. I'm here, I'm not, I'm here, I'm not. Oh, you got to add the same thing. So this question says, what's the probability that I pick, if I pick one person at random, what's probably, I pick somebody who moved within the same state. So do I know anything about the person? Have they given me any information? No. So what's going to be on the bottom? 39. It's going to still be everybody. Now what do I put on the top?
30.4.
Yeah, how many match what I'm looking for? 30.4 total millions of people moved within the same state. And then you can just divide that, see what you get. So see what I meant? If this is 30.4 million and that's 39 million, okay, the millions cancel, so that's why you don't need to write all those zeros. Dear God, don't do that to yourself. How are we doing there? That's the basic fundamental idea of probability. The bottom is everything that could have happened, and the top is specifically how many match what you're looking for. Right? That's how probability works at the base level. What about this question? What's probably that somebody moved to a different state given that they're a renter? So what's going to be on the bottom now? Given that they're a renter. Total renters. So, okay, so 24.2. Out of those 24.2 million people, how many moved to a different state? No, that's counting way too many people. What's the only people I'm looking at? These people. 4.5. It couldn't be this, because then you're counting these people. How can I be counting these people when I know it was one of them are people? I'm one of them are people. Do you guys see that? So given, the probability idea probably never changes. The bottom is always the total number of things it could be, and the top is always what matches what you're looking for. So if I tell you they're renter, then only this many things could have happened. Out of those many things, how many match what I'm looking for? That goes on the top. See, so the formula actually never changes. To be honest, it really doesn't. The formula looks different, but it doesn't really change the idea. Maybe? Okay, good. Let me push my luck. What about probably somebody moves to the same state and they're an owner? For some reason, people get confused with the one we just did. Do you know anything about the person? Not a damn thing. The probability that they moved to the same state and they're an owner. I didn't give you any information, so what's going to be on the bottom? 39. So the bottom only changes when I tell you something about the person. Otherwise, you got to include everybody. Now, how many match what I'm looking for? What I'm looking for is very restrictive because they have to be what and what. They have to be same state and owner. Well, how many people are both of those at the same time? 11.7 million, yeah. When I always get people add stuff, no. In English, that's allowed with the word and. In English, the word and means several different things. In math, it means you must do this and this. So it's always going to be a smaller number than either one. Did I tell you about the evil bouncer and the nice bouncer? Right? He's the evil man. He lets fewer and fewer people into the club. Definitely keeps me out. And then whatever the hell that is. When you divide it. Alright, I like it. Right.
Shouldn't that be 14.9?
I don't know. Where are we at?
For owners, shouldn't it be 14.9 instead of 8?
Oh yeah, 14 point. Well, no, 12, 14.8. Yeah, I'm not sure. 7 and 8 is 15 and 3 is 18. Yeah. Always do that though. Double check, and you never know. Raw.